get shagoomy. The lake, it is said, never gives up her dead when the skies of November turn gloomy. With a load of...
Alright, here. So for our first step for doing the equilibrium with the ice tables, first you have to construct an ice table. Right here we have some ice that goes on your wrist. Right here. So for an ice table you put I, C, E. This stands for initial change equilibrium. Then you put the products and reactants up top. So we have N squared, that's gonna be nitrogen, oxygen, and then we're gonna have some gas here. Step 2, decide what information is given and insert into table. Now from the problem, we know that the initial partial pressure of nitrogen is 0.675 atm. We also know that the initial partial pressure of 0.4 of oxygen is 0.472 atm. Since there was only reactants in the container, we also know that the initial partial pressure of this is 0.
So, step 3, determine the change based on molar amounts. So, what we're gonna do here is we're gonna look at the original reaction and we're gonna look at the coefficients. So, nitrogen has a coefficient of 1, so it's gonna be minus 1x. Oxygen has a coefficient of 1, so it's gonna be minus 1x. And this has a coefficient of 2, and it's a product, so it's gonna be plus 2x.
Alright, for step 4, we're gonna find the equilibrium by adding change to the initial. So we're gonna combine these 2 rows. So we're gonna take 0.675 minus 1x, 0.472 minus x. And then since this is 0, this is just gonna be plus 2x. Next, we have to solve for x. In order to do that, we have to first write the Kp equilibrium. In this case, it will be Kp equals PNO squared. We use parentheses because we are talking about a gas. In the denominator, we will have PN2 and PO2. Now, in order to solve for x, we substitute these previous values into this equation. We're just going to make up a number for the original Kp, saying that Kp at equilibrium is 4.8 times 10 to the negative 31. Next, we have to substitute these values into this equation. So, the first part, we start with 2x in the numerator. So we leave 2x squared over 0.675 minus x times 0.472 disregard these x's because the number will be so astronomically insignificant. Alright, so we're gonna finish in simplifying this. So we have these two values, and that's gonna simplify to 0.359 over 4x squared. So now all we have to do is use this. There's a single x, so we just solve for x. And I know that x is equal to the square root of 0.319 times 4.8 e to the negative 31 over 4. And then this, once you just put it all in your calculator, it's gonna come to this final value, which is the x value, which is 2 times 10 to the negative 16. So this is the final value we need.
So since we know that x is equal to 2 times 10 to the negative 16, we can then exchange that x value for our original e in our equation. So once you do that and put it in a calculator, the NO is going to be equal to 4 times 10 to the negative 16. The O is going to be equal to 0.472, and the N is going to be equal to 0.675 ATM, and these are all in atmospheres. And that's your final answer.
That's how you do an ice table!